PCTG. You've probably heard the name thrown around as the tougher, more heat-resistant cousin of PETG, but is it really worth the hype? Today, we're testing out a US-made version from a company called American Filament based out of Huntsville, Alabama. But first, if you're new here, my name is Billy, this is my workshop, and you're watching KHR Entertainment. So one thing that sparked this video, aside from a pretty compelling social media ad campaign from American Filament that eventually won me over, was hearing Jonathan Levy from The Next Layer talk about PCTG being a better PETG, less hygroscopic, easier to print, and doesn't behave like wet spaghetti if you forget to dry it before using it. And before anyone asks, this is not a sponsored video. American Filament has no idea that I'm making this video, and I don't have any affiliate links or any other connection with the company other than the fact that I fell for their marketing campaign. I ordered two spools from them, Blizzard White and Obsidian Black. And I opened the Blizzard White as soon as I received it and left it out on my bench, along with a spool of PETG-HF from Bambu Labs and a spool of started Inland PETG PLUS. These have been out for almost 3 weeks now, sitting on my bench at relative 50% humidity. So this will be a really good test to see how these print when you just leave them in open air and you don't store them in a dry box. I'm also going to put it up against a spool of CoPE or CoPE by Polymaker. And this stuff has been sitting out since I made that first video in January. And I just printed with it a couple of days ago on the Prusa XL, and it's still printing perfect. So this will be a really good comparison to see. So before we jump into the stringing test, let's open a fresh spool and cover the basics. And do note that this bag is far from airtight, even though this is how I received it. So we're going to do these first few tests on the Bambu H2D. I'm going to load the PCTG in a Polymaker dry box on the left extruder, and I will load the PETG that we just opened in the AMS-2 Pro so it can be channeled to the right nozzle. American Filament does have a Bambu Lab profile for their PCTG on their website, but I actually wanted to try this just with Bambu's built-in generic PCTG profile first time around. So I'm going to load that now, and then I'm going to load the Sunlu PETG-HF using the generic PETG-HF profile as well. Now we're jumping over to Bambu Studio, and the first thing we're going to print with this material is just an all-in-one printer test. So we cover all of our bases in one shot. This is built into Bambu Studio, and then I believe Orca Slicer has something very similar built in as well. I'm adding two of them, and I'm going to assign the PCTG to the left nozzle and the PETG to the right nozzle, and I will switch them into print by object mode so they print one after the other, starting with the PCTG first. Let's get these guys sliced and send it on over, and we could check this out shortly.
I wanna buy some American film. Just one spool, I sold off the internet. Did I just fly into hysteria? Is this PCTG a great area? Welcome to a brand new obsession.
Now, while the H2D is chugging along with our dry filament, let's take a look at the spools we left out, specifically to test their printability, especially stringing, which is a huge pain point for regular PETG. So we have our dry PCTG and PETG printing in the H2D. So now on this test, we're going to see how improperly stored filament behaves. And as mentioned earlier, we're comparing PCTG, PETG-HF, PETG Plus, and CoPE. We're going to load each one of these into its own toolhead on the Prusa XL and print these tests in print by object mode. For the test object, we're going to use this really tough stringing test that I found on MakerWorld. Materials like PCTG are great because they enable engineering-grade print jobs to be accessible to all makers, not just those who have enclosed or heated machines like the H2D. The TDS itself even states that it can be printed on open-air machines, just like the Prusa XL. So I actually do have an enclosure for this Prusa XL. What I don't have at the moment is space for an enclosure. So rigging my filament on the SCADAS panels or overhead for this machine was the most practical approach for me in terms of space. And that just so happens to work to our benefit for the sake of this test. Okay, now we're in Orca Slicer, and we have each one assigned to a different extruder with the different materials. So let's get this all finished up and send it over to the printer and see how this rolls out.
Since this bull says it's made in America, I can dodge that whole tariff agenda.
Before we go back to the Prusa, we could check in on this all-in-one printer test over on the H2D, and it is coming out really clean.
I wanna buy some American filament. Just one spool, I scored off the internet.
All right, the stringing test is complete. And here is the first one, the Bambu PETG-HF. As you can see, it failed miserably, but this was to be expected. It's been sitting out at 50 degrees relative humidity for 3 weeks. Copolyester, really no stringing at all. We did have bed adhesion issues, but we had that on most of the other prints, and that's honestly because the first object printed was PETG, so the Prusa set the bed temperature as if everything was PETG. So copolyester and PCTG have slightly different bed temperature requirements, so they wound up peeling a little bit on the corners. So that aside, stringing was not an issue, and this has been out in open air since January when I filmed the first video about copolyester. PETG Plus actually didn't string too bad, but it still had issues. Like, it is incredibly weak and brittle, and it just fell apart during the print. So stringing wasn't terrible, but it still had moisture-related problems, and it fell apart. And now, PCTG. We had this little bit of stringing at the end from the tool head lifting straight up, but in between the post, it's actually pretty clean. I really don't see any stringing between the posts at all. And then, like I said, this was just because the bed was not set to the ideal temperature for this material. So the corners lifted a little bit, but the stringing is really not there. So this is a good material to use if you don't have an enclosure, and if you can't always keep your material in a dedicated dry box or an AMS, if it has to be, you know, out in the open air like these, this is a good choice.
Did I just fly into hysteria? Is this PCTG a great area?
All right, well, PCTG on the H2D, right out of the package, printed really good. I mean, there's a tiny bit of like wispy stringing going on there. Sunlu PETG-HF right out of the package, not so good of an experience going on right now. So we're gonna stop this before it destroys that nozzle. Okay, let's take a look at our all-in-one printer test that we did on the H2D. This is the black PCTG that came right from the package. It was not dried. All right, so right out of the printer, I did this, and these pieces went flying. So the tolerances are on point. My Stormtrooper just fell over. So the tolerances are on point, and this printed really clean. This is a very glossy material. We're gonna get to that next. Now, there is a tiny bit of stringing, but for something that just came out of the package, that's not bad at all. And this I broke, again, taking it off the printer. This printed fine, but I grabbed it and almost dropped it and broke that piece. So ignore that. But overall, this is a really clean print. And again, this is usually a test to determine how well the printer is working, not the material. I mainly wanted to print it for the stringing. But overall, clean print and solid material for this that didn't require being dried. All right, let's reset the Prusa and let's do a multi-material test. Now, let's see how well PCTG adheres to 4 of the most common materials in 3D printing that don't need enclosures: PLA, PETG-HF, CoPE, and TPU. PCTG is centered, surrounded by the others, and some of them will have multi-material interlocking turned on, and the others will be flat joints. So we're going to leave the PCTG and the PETG PETG-HF in the Prusa, as well as the orange copolyester, which you can't see right now, but it's loaded into toolhead number 5. We're going to get rid of this blue copolyester, which was from a previous project. We're going to remove the inland PETG Plus and swap that out for some TPU. You can see that multi-material interlock happening here, whereas this one doesn't have it. It's just butted right up against one another. While we wait for the PCTG to finish printing, I wanted to take a moment to thank today's sponsor, UGREEN Technologies. Let's take a walk over to my office and see what they sent. If you've been following the channel for any bit of time now, you're probably used to seeing my workshop being all tidy and organized, but my office is a different story. And that's where today's sponsor is going to come in, because sometimes your desk just becomes a disaster. Cables, dongles, mismatched chargers, everything you swore you'd organize today, but maybe you'll get to it next week. Enough is enough though, because this week I finally tackled the chaos with one device that replaced half of what you just saw, the UGREEN Revodok Max Thunderbolt 5 docking station. With a single Thunderbolt 5 cable, I can now power my MacBook, run a 36-inch ultra-wide display, connect multiple hard drives and accessories, and even my audio interface, all through one sleek dock. And if your monitor doesn't support Thunderbolt directly, fear not, because you could always use a UGREEN Thunderbolt 2 DisplayPort or HDMI cable, which is what I'm doing. It works flawlessly, and it's a simple fix that makes the dock compatible with almost any HDMI or DisplayPort monitor, no matter how old they are. With that single cable, it delivers up to 120 gigabits per second of total bandwidth via Thunderbolt 5, and 140 watts of dynamic charging power via power delivery by way of the 180 watt GAN adapter that's included. Now, this dock supports up to dual 6K displays at 60 Hz or a single 8K display. Now, I don't have either of those, but I do have a 36-inch ultra-wide 4K display, and it works perfectly with that. There's also a 2.5 gigabit Ethernet port, 5 USB ports, and enough connectivity overall to make any setup feel high-end. Plus, it has regular SD and TF 4.0 card slots on the front that can provide up to 312 megabytes per second of transfer speed. Perfect for offloading 4K footage for someone like me that's a content creator. The dock is completely plug and play with Windows or Mac. You don't need any additional software to make it work. As I mentioned, the biggest benefit of this dock is that you only need a single cable to tame everything, or one cable to rule them all, as I like to say. But since this is a 3D printing channel, we can make it even better. I found this awesome hands-free MacBook cradle on MakerWorld, and I printed it on my H2D, and now I just slide my MacBook in with one hand and watch everything come to life. The dock itself is built with a dual-layer aluminum construction that allows for optimal cooling and keeps things running efficiently and safely even under heavy loads. And you know what? There's even a power button right on the front, which lets me put the whole unit to sleep or wake it up with a single press. It sounds minor, but believe me, it's not. Many other docks on the market don't have this, and you either have to unplug your laptop or put your computer to sleep with the mouse and keyboard. What is this, 2015? So if you're tired of desktop clutter and you want your office to look as clean as your workshop, the Revodok Max might be for you. Get yours using the link in the description below and help support the channel. And now, back to the PCTG. All right, let's take a look at our multi-material test. So right here we can see that, PLA didn't adhere at all. TPU didn't adhere at all. Let's see. CoPE and PCTG are actually bound pretty strong. Look at that, didn't even all break at the joint. Some of it actually stayed on there. PETG, not as good as the CoPE and PCTG. I expected these all to have some type of intermingling properties, for lack of a better term, because they are all copolyesters. They're all different types of copolyesters. So it's not so, it's not so great that I wasn't able to just pull the raft off. So you could still get them apart, but they are somewhat compatible. All right, so let's take a look. Now this one has Orca Slicer's multi-material interlocking properties enabled, so I expect this one to be a little tougher. Let's get the raft off. And honestly, these are probably not going to break at the joints because of that, but yeah, TPU is on there. Even the PLA. Oh, there we go. Broke on the PLA side of it. Not surprising. Oh, that was interesting. I would guess that that probably broke on the PETG side, but it did break right along the seam. These... Okay, there we go. You can clearly see which is the stronger of those two materials. This is not going to break. There's too much flex in that. I'm not going to be able to break that. All right, let's take a look at the next ones. Now, these were printed vertically, so we're going to be testing like the layer adhesion. Oh, well, there you go. PLA completely came off, no problem at all. So that would actually be a good support material for them. TPU, same. All right. PETG. They bonded pretty well. That's not coming apart. Same with this. So printing vertically, one layer on top of the other, these bond pretty well. So CoPE and PETG have some pretty good compatibility with PCTG. Honestly, these are going to be the same thing. These are the ones with multi-material interlocking turned on. So I expect they're not going to separate that easily. Yeah, I'm not going to be able to break these probably unless I use pliers. So if you need to mix materials that are not natively compatible, this is the way to do it. So you can mix materials that don't chemically bond to one another. All right, cool. We know some of its compatibility properties now, and we can move on to a functional print. If you want to see more about how PCTG compares to CoPE and other materials, be sure to subscribe and follow me on social media, as I'll be doing a full mechanical showdown, pitting PCTG against CoPE, Filament CPE, and some other materials using my new push-pull testing rig and my impact testing rig that's still being built. So check back soon for that, and we'll really see which of these materials truly deserves the crown. One PCTG claim that I heard about that intrigued me is that it's dishwasher safe. So naturally, I wanted to test that. And those of you that are familiar with this channel also know that I like to print something practical or functional in all of my videos. So today, we're going to tackle a little annoyance that I recently had in the kitchen, which would be these cocktail skewers. They constantly fall over and out of my cabinet and into the sink, and then I need to wash them. And then that presents a new problem because they're too small to actually be held anywhere safely in my dishwasher without falling to the bottom. So I printed this perforated container on MakerWorld, and I printed it out of the white PCTG. I also printed one out of PETG for comparison, and the skewers fit in there nicely. Plus it has a threaded lid. So let's go take this over to the dishwasher and see what happens. All right, the dishwasher's done. Let's take a look. So far, so good. The PETG survived too. Let's see. The threads work. It feels structurally intact. These annoying little things are clean. All right. PETG. Oh. All right. Well, there you go. PETG probably didn't like that extreme heat for that long. It made it a little brittle. Well, there you go. PCTG, I mean, I'm pressing on that just as hard, if not harder, than the PETG, and it is not cracking. Cool. All right, so this is dishwasher safe, I would say. I still wouldn't recommend using it on anything that's going to come in direct contact with food because, FDM printing isn't exactly meant for that. But for this, for putting copper pieces in there that just need to be washed and sterilized, totally fine. And I will probably print other things that might have to go in the dishwasher now that I know this will survive. Now, I purchased this PCTG for its functional properties, but it has such a nice finish. I kind of want to put it through its paces for its aesthetics as well, which is a little unusual for me since I'm not the biggest multicolor ornamental printer. But with that said, I had the perfect idea since it's white and black, which by the way, now they have, I think, 7 colors available. They only had white, black, and gray when I first ordered it. But anyway, this is a urban Stormtrooper figurine that I designed for May the 4th to complement the very popular and viral urban Darth Vader that came out. Now, I designed this using Dolly and Maker World's image to 3D model tool. I'll make this model available in the description for anyone that wants it. Now, this one I printed, around May the 4th in just matte PLA, white and black, 2 colors. But now I have one going in the H2D out of the glacial white and obsidian black PCTG. So let's see how this comes out.
Welcome to a brand new obsession. Run out my own recession. This spool says it's made in America. I can dodge that whole tariff agenda. Who wanna swallow that flashy propaganda? I'll avoid all that tax paranoia.
All right, we have our Stormtrooper, and it's got a little bit of crud on him, but that was because the prime tower fell over, so that wasn't a fault of the material at all. Let's see how easy these break off. Pretty good. Okay. As you can see, I shrunk him down quite a bit from the original one because this video is getting pretty lengthy, and I have others to shoot, and I just needed to print him a little faster. So we've got a little mini Stormtrooper, urban Stormtrooper, and he came out really clean. This is I do wish the finish variants kind of worked like they claimed, that if I would have changed the temperature, I could have got the sweatsuit to be more matte and just his helmet to be shiny without using different material. That, I'll play with that some more in the future, but so far I haven't seen that happen. So that is one claim that they're making that I'm not seeing happen in real life. That's an interesting little artifact there. Kind of like the printer failed on that overhang and it didn't know to put a support there. But overall, I do really like the finish. Like if I was looking to make something glossy, this is excellent. This, it's so normally you see layer lines on glossy, but this isn't that bad. I'm seeing a little bit there. I did use variable layer height to try and speed up the print, so I should probably print another one of these with just 0.12 millimeter altogether and not try to sacrifice quality for print time. But still, overall, this is a nice looking aesthetic material as well. And I would print out of this for something that, isn't quite functional. If I just need it to look nice and I need it to be glossy, why not? Well, we covered a good deal here today, but there's still more to come, including that mechanical showdown I mentioned. Oh, and I've been dying to see just how fast I can push this stuff. Do you have any ideas on what I should test to see if it could print at, say, 500 millimeters a second? Maybe some speed Gridfinity bins? Let me know in the comments below if that's something you'd like to see and what ideas you have for something that would be a challenging print at high speeds. If you like this video, be sure to share it with your friends, like and subscribe, and turn on those notifications so you don't miss anything. And before you go, check out some of my other videos as well. Links for everything featured today are in the description below. Thank you again to UGREEN for sponsoring this video, and thank you guys for watching. I'll see you on the next one.